Hi everyone. In this session, we are going to discuss about power. In common life, we always use the word power. The power of a man, the power of a motor. Right? No? And what is meant by power? It is a rate of doing work by a body. Okay. It is a rate of doing work by a body. Or in terms of equation, we can represent it as power is represented by the letter P. Pressure also we used to represent by P, but both are different quantities. Okay. Power is equal to work done by time. Okay. Power is equal to work done divided by time. So rate of doing work done is known as the power varies for different bodies. Okay. Let's see an example. Just consider two members. Both are carrying equal amount of weight to a particular distance. Okay. Like from first floor to second floor. Okay. Just consider that. What is the equation to find out work done? Work done is equal to force into distance. Okay. Consider that both are carrying 10 kilogram force to a distance of 10 meter. Okay. Both are carrying it to a 10 meter. The first one, the person one completed it within 2 seconds. Okay, the first one kept the object within 2 seconds and the second one took only 1 second to keep the material. Okay, let's see which person has more power. So, person 1 power is equal to 10 into 10. Same distance and same weight divided by 2 seconds. Okay. So 20 by 2 is equal to 10. Okay. I will mention the unit right now. Just wait. Then P2 is equal to 10 into 10 divided by 1 second. We will get 20 by 1, that is equal to 20. Okay. Now we will find out the unit. What is a unit of work done? It is joule. Right? What's the unit of time? It is second. So the unit of power is joule per second, or we used to call it with a common term, that is watt. This is also given on the honor of a scientist called James Prescott Watt. Okay. So what's the unit of this one? Joule per second, or we can write it as watt. Okay. Joule per second or watt. Here also watt. So see, first person the power is 10 watts and for the second person the power is 20 watts. So as if they did the same work, the second person took only less time. So he has more energy. Okay. This work done we can consider it as energy also, or we can write work done is equal to power into time. Okay, or else we can write it as energy is equal to power into time. Energy, we know that the unit of work done is joule, so that is equivalent to the energy. What is energy? It is a capacity to do work. Okay, it's a capacity to do work. If we pay the electrical energy, all these, that unit will come in terms of kilowatt hour. Okay, how we'll get that? Let's see that. What is the unit of power? It is watt. What is the unit of time? It is second. Okay, just consider that a material or an electrical machine having a power of 1 kilowatt work for 1 hour. Okay, a 1 kilowatt motor is working for 1 hour. So electrical energy consumed is equal to 1 kilowatt hour. Power into time. Okay, so this is the way we used to calculate the electrical energy, and how much we consumed. According to that, we have to pay electrical bill. We know that we always mention the power of bulb with watts, 100 watts, 60 watts. What does it mean? If it is 60 watt bulb, what does it mean? It means that 60 joule energy consumed in 1 second. Okay, 60 watt bulb means it consumes 60 joule in 1 second. Okay, joule per second. So that's why we got the value as always we will get the value as 60 watts. Now let's see the bigger units of power. So 1 joule per second is equal to 1 watt. Same way 1 kilojoule per second is equal to 1 kilowatt. That means 1000 watts. Okay. But in some of the mechanical purpose or in the production place, especially as in the case of vehicles, okay, the power will be mentioned in terms of horsepower. Okay, the power is mentioned in terms of horsepower. So 1 horsepower is equal to 746 watts. Okay, 1 horsepower is equal to 746 watts. If you see the conversion of 1 kilowatt hour, we can write it as 3.6 into 10 to the power 6 joule. And 1 horsepower is equal to 746 watts. Okay, keep these two values in your mind. Let's see the factors affecting the power. Which are the factors affecting the power? We know that power is equal to work done by time. From the equation itself, we can mention that work done is the first factor. As the work done is more, the power is also more. Second factor is time. As the time increases, the power reduces. It's a denominator factor. Okay. So power is directly proportional to work done and power is inversely proportional to time taken. So work done and the time, these are the two factors, depends upon the power. Now let's see the difference between work and power. What is work? Work is a product of force into distance. And what is power? Power is rate of doing work or work divided by time. Okay, second one. Is it any time factor is here? No. So, not depend on time. Here, time factor is here. So, it depend on time. Okay. Third one. What is the unit of work? The SI unit is joule. And here, the SI unit is watt. So, these are the three main differences between work and power. Let's see the difference between energy and power. If you compare and study, both the differences are easy to study. First one, energy and power. What is energy? It's a capacity to do work. First one, capacity to do work. Okay. And here, same way, it is a rate of doing work. W by T. Power is equal to rate of doing work. If you see the second and third point, energy does not depend on time, it depends on time. Unit, joule and watt. Okay. So the 2 and 3 points are same points, the same difference between work and power. So compare and study, only you want to study the first part. Here the definition for energy, it's a capacity to do work. On the right side, all the three factors are same. Thank you.